Good morning, children. Welcome back to ICAN Physics Academy. Now, in this class, we are going to solve the fifth lesson, third problem, and fourth problem. Let's enjoy the class. Okay. Next, 5.3. A sharp bar magnet placed with its axis at 30 degree. So, theta equal to 30 degree. With a uniform external magnetic field. Okay. So, magnetic field 0.25 Tesla. Experiences a torque. Okay. So, torque tau equal to 4.5 into 10 to the power minus 2 joule. Okay. What is the magnitude of magnetic moment of the magnets? Okay. So, torque tau equal to M.B sin theta. Torque. So, what is the value of torque? 4.5 into 10 to the power minus 2. Magnetic moment, that only we are going to calculate. Into magnetic field, 0.25 Tesla. Into sin theta. So, what is the value of theta? 30. So, sin 30. Okay. So, M into 0.25. Sin 30 is 1 by 2. Now, take all the terms to the left side. Okay. So, 4.5 into 10 to the power minus 2. The division 2 comes to this side as multiplication. Divided by. The multiplication 0.25 comes to this side as division. Equal to M. So, now by solving this one, we can get 0.36. 0.36. This much of magnetic moment. So, what is the unit of magnetic moment? Joule per Tesla. Okay. Do you get it now? Do you have any doubts? No doubts. Now, we can go to the next question. A short bar magnet of magnetic moment. Okay. 0.32 Tesla. Okay. So, magnetic moment is 0.32 Joule per Tesla. Okay. Is placed in a uniform magnetic field of 0.15 Tesla. If the bar magnet is free to rotate in a plane, okay, which orientation would correspond to its stable and unstable equilibrium? What is the potential energy of the magnet in each case? Okay. So for stable, what about the angle? The theta is 0. Okay. So what is the electrostatic potential energy? That is minus M.B cos theta. Okay. M. So what is the value of M? 0.32 into magnetic field 0.15 into cos 0. Cos theta. Cos 0. Cos 0, 1. So 1 into something. So what is the value? Minus 4.8 into 10 to the power minus 2 is the electrostatic potential energy. So its unit is joule. For which case? For stable. Okay. For unstable, it orient in the opposite direction. So for unstable case, the theta equal to 180. Then cos 180 is minus 1. So the same formula. So potential energy is minus M.B cos theta. So minus M. So 0.32 into B 0.15 into cos theta. Cos 180. So what is the value of cos 180? Minus 1. So minus 0.32 into 0.15 into minus 1. So minus into minus plus. So once again we are getting the same value, but we are having plus 4.8 into 10 to the power minus 2. This much of joule. This is the energy for unstable equilibrium. Okay. Do you get it now? Do you have any doubts? No doubts.